Yeah, recording. Okay, chat. Hi, Kathleen. What can I do for you? So this is the ice task. If you want to use your microphone, you're welcome to do that too. Okay, so the chi-squared test is another type of hypothesis test. Hypothesis test is learning unit 5. If you are really confused about hypothesis tests, then you really need to actually just look at that. With a hypothesis test, you have a null hypothesis and an alternative hypothesis, which is what, can I select that? No, I can't. Pointer, which is what these are over here. So we need to kind of look here and go, right. We are being asked a question. We have got a sample, and now we need to determine if it is, I keep on looking in the wrong place, sorry. We need to determine if it is going to be statistically provable or statistically rejected. So that's where we're starting with there. So let's start off with something very easy. What do you think the level of significance is? Just take your time, read the question, and tell me what this level of significance is. Okay, that's fine, though you generally want to put it as a percentage. So yeah, we've got 5%. So let's just clear this and put it over here. 5%. Yes, that's what you're going to be looking with. That's what you're going to be working with here. Anyway, so we've got 5%. Now we kind of have to look here and go, right, what's the question that we're asking here? And you want to phrase it statistically. So what do you think the question is? I'll even give you a clue. It starts over here. Okay, now how do we make that a question statement? We need two. We need one saying that, we need one thing stating the one way, and we need one stating the other way. So how do you think you'll phrase that? Okay, well, look at it this way. Does the survey support the manager's belief that male characters appear more than female characters? Okay. If the survey does support the manager's belief, what is happening? Answer that question. If the survey supports the manager's belief, what has happened? I'm just going through the textbook just to double check something before we get to that there. If you're wondering why I'm paging through. But yeah, answer that question. Okay. And if the survey doesn't support the belief, what does that mean? Okay. What we could actually say here is that the distribution is equal. So that what you said is not necessarily wrong, but generally what you're dealing with in chi-squared, and it's not a bad habit to have, is you're kind of going, right, there is no bias or there is bias. And I don't mean this in particular of gender bias, I mean this in general. There is bias or there isn't bias. And generally, or almost always at Varsity College, your there is no bias will be H0. So this will be no, whoops, bias. Yes, I know. Actually, I can do this better. Aha. Oops. Oops. Like that. And over there, we'll change the color to orange. Okay. So that's now roughly what our hypothesis tests are. What we'd be looking for is going that the manager's belief is incorrect and the genders appear equally. And we'd have over here, there is the manager's belief is supported that there is gender bias towards males or something along those lines. Okay, we've already got the levels of significance, so we can go over here and go 0.05. Just want to think about something, I want to go back there. Okay, now we need to look at the degrees of freedom. The degrees of freedom actually come after filling in the table. Okay. So to do the degrees of freedom comes in after. Am I not going into this? Sorry, something's gone wrong here. Okay, anyway, so now we need to fill in the table. And with chi-squares, you have to have tables. So we're going to have a table that kind of goes like this. And you'll have over here, we'll have boxes. I'll change the color again. Appearance on boxes. Does this work? No. And then we'll over here, we'll have males. Here we'll have females. And over here, we'll have total. Okay. So what are these numbers? This will make a little bit more sense in terms of why it always happens when we finish the table. camera there, text there. Hi. Males 996. Okay, cool. So we go there, 996. Females 390, and the total. 1386. Okay, cool. So none of this is rocket science just yet. We've now got our table, and all of these numbers are from the question. At Varsity College, they generally give you the table as the question, so you don't have to worry about constructing it, but you have to have a table to do chi-squared. So now we can go, well, why did I say that my null hypothesis, which is my H0, is both genders appear evenly? Because of how this one works, expected frequency. Because I need to know what my expected is to populate that table. And that will make more sense in about 2 minutes, so we'll leave that for now. So the degrees of freedom, we're going to leave this one for now. Okay, there's a very good reason why we're leaving this one for now, because it actually can come in after step 4. So step 4, let's go bit by bit. What is my observed frequency? This is not a trick question, you know this one. What is my observed frequency? Yes. And females will be 390 again. Okay. Now we can kind of go, well, what is my expected frequency? Now, for my expected frequency, I look back to my null hypothesis. And my null hypothesis says both genders appear evenly, which means it's going to be 50-50 split, right? That's a very good question. Now, we are expecting our sample to be evenly split, right? You follow that? We've done a sample, we've got our results, we now want our sample to be evenly split. No. You're splitting this number by the ratio. Okay. So what do you think this number is going to be? So my VC alone is messing up on the side here. There we go. Okay. So it's going to be just a nice and easy 1386 divided by 2, which gives me 693 there and 93 there. Right? You agree with that? Now we have this O minus E. Well, what is O? O is observed frequency, and what is E? E is expected frequency. I'll wait for typing. Yes. Okay. No. No, that went wrong. It's not O1 minus O2, it's O minus E. So it's going to be male O minus male E gives me a number, and we'll have female O minus female E, which will give me a number. Yes. Well, what you did in the chat was you went male minus female to get 606, which is not right. So you used the wrong numbers. You wanted to use 396 minus 693, but yes, that's 303. And this is not always true, but for this one, this is going to be minus 303. Yes. Okay. Now, you don't have to worry about the minus number, because what we actually care about is this number at the end. That's the only one we really care about. So this is just a step towards that step, towards this step, towards the answer we actually care about. Okay, so you don't have to worry about the minus number. Now we square both of these. And we get and a negative squared is the same as a positive number squared, so it'll be the same number. Okay, if I just note this is the same column, I don't really, like in terms of marking, I don't really care about this number, I only really care about this one here. This is the only number I care about in this whole table, but this is just the steps to get it. So now we've got 91809, and we're going over the expected frequency. So what number is going to go into this column? So now we got 91809, and we divide by 693, and we're going to get 132.48, and again on the bottom one, 132.48. Okay, so that's this table done now. Not so scary. It's very straightforward maths. It's just typing in numbers into your calculator. This table here, so I'm going to get that now. This table here is the most marks for this question, which is why it's a 10-mark question versus a 6-mark question for hypothesis testing. Be right back. Sorry about that. So this table is worth the most marks in this question, always. Because you can see there's quite a lot of calculations going. So you can actually get this table right, get everything else wrong, and still pass the question, which would be interesting, but it's possible. You should get the hypothesis testing right, the hypothesis statement right because of the expected frequency though. So carrying on. Now we need to get our test statistic. Now in hypothesis testing, we have a critical value that we're comparing to, and we're comparing our test statistic to that. The test statistic is always calculated. In an hypothesis test, that's when you're using your x bar minus mu over your standard error. In chi-squared, our test statistic is calculated from this table, and all we do is we sum, I'm going to use a different color, we sum this column. Okay, so we sum that column to get our test statistic. So what do you think the test statistic is? Yes. Okay, so now we've got our test statistic. Now we need to find our critical statistic. These are generally sorted to shortened to like chi-test and chi-crit. Okay, what the critical value is the number that we are comparing to. Now to find the critical value, we need to know what degrees of freedom we're looking at, because we're going to go to a table at the back of the textbook. So find the degrees of freedom. It changes if it's on a single column table versus a dual column. So this is a single column table because we've got our numbers only in one column. If, for instance, I had appearance on boxes and then I had appearance on milk cartons, we then do a different degrees of freedom. But all you do for degrees of freedom is you look over here for your single column and you count the number of rows and you minus 1. So how many rows of information do I have here? No. The total is not actually information. The total is derived information because the total comes from the males and the females. So I've got 2. Now, for degrees of freedom, I treat it exactly like a t-test, and I go n minus 1, which gives me a degrees of freedom of no. Number of rows, remember? How many rows do I have? 2. 2 minus 1 is? Yes, I did just ask that. Yes, so we've got degrees of freedom of 1. So now we can go to our textbook, which is page 'I'm finding it on the textbook for you. I do actually have it here, but as soon as I change away, it's everything I've written, so that is going to be sad. But we have a textbook on page 474. Page 474. Okay. Page 474. Okay, cool. Now, let's look for the degrees of freedom column. Do you see it there? Cool. It's the first column. So now we go down the first column and we go row by row until we find the number 1. This will take a long time, I'm sure. Do you have the first row? Cool. Now, remember our significance level is a significance level of 0.05, which is the same as 5%. What column, just counting from the left, so as I said, the first column is column 1 with your degrees of freedom. What column is 0.05? Or my 5%? Yes, we could just go there too. That works, yes. So my critical value is 3.841. Okay. Now, what I do is I compare my test statistic to my critical value. They compare very well. My test statistic is massive compared to my critical value. So do you think that means that there's gender bias here? Okay, so that means we've got a conclusion of there is gender bias. So now in chat, I would like you to tell me how we conclude this. That's one part of the answer. No, you don't need to state the difference. You want to be saying something along the lines of, because remember we have to state whether we accept or reject the null hypothesis. I mean, we've stated these hypotheses. These are what we're testing. This is what we're testing. So we need to actually say, like, well, what are we doing with them? Well, we reject the null hypothesis, full stop. At a 5% level of significance, there is statistical evidence to support that males appear more often on cereal boxes or whatever, on cereal boxes than females. Okay. I need to see the level of significance. And if you think about it, why I need to see it is because what happens if we were testing at a 10% level? Well, the number changes. I do not think there is any level that I would actually accept. Let me just check this. Yeah. And that's how you do this one, and that's how you do hypothesis testing in a nutshell. In a nutshell, there's a little bit more to it. And for the chi-squared tests where you actually have more columns than just the one, your degrees of freedom become n-1 for your rows, and you multiply that by n-1 for your number of columns. So if I had another column over here with another two sets of data, so if I had another column and then I had information there and I had information there, my degrees of freedom would be n-1 times n-1. Except this would be for columns and this would be for rows. Well, it's basically the answer that I just talked you through, so it should have helped a lot. Yeah, if you kind of just give me everything that as we've done here, it's full marks. Is there anything else you want me to help you with, since you're the only one who actually bothered to turn up? I'm very tempted to not make this video recording available, just to kind of go to the rest of the class, but I'll probably put it in. And yes, that means that is actually in the video. So to those who watch this, lucky you. Yes, and what that one's going to be doing, what I'm going to do there is I'm going to have 2 hypothesis test questions and 2 chi-squared hypothesis test questions, and we'll do that in the first session, and in the second session we'll mark them. It'll probably be 20 to 30 marks. Yeah, I do recommend you submit this one for your ICE if you can, because the one on Monday is actually going to be a test. It's like basically the level of the questions will be test level, or as close as I can get them to it. So yeah. Anyway. Have a good weekend. Okay. Thanks. If you still need those, you can find them in the video that will be up after this. So yeah, I'm recording. So if you didn't take down something for any reason, you can always just find it in the video. Yeah.